Hi there guys, today we're going to set up a PID loop on a Vacon 20 HVAC drive. First thing we're going to do is we're going to reset the drive to factory defaults. We go down to System, 4.2, and we make that a 1. That's going to reset the drive to factory defaults. First setting it gives us there, 1.3 is the motor speed. Choose that according to your motor data. You've got your amps is the next one. Motor data, you're going to get that. 17.1 is application, so we can choose there between basic, pumps or fans. I've got a fan connected to this. A fan is number 2. We're going to choose that. We then need to open some additional parameters. So it's gone to monitor there. We need to go back to parameters. And then under parameters we go to 17.2. And we change the 1 to a 0, and that will unlock some additional parameters for us. The next parameter we're going to do is 2.1. 2.1 is the remote control place. You get to choose I/O or keypad under there. 0 is I/O, 1 is keypad. We're going to use I/O here, so that's default. We're going to keep that the same. 2.4 is my next one. 2.4 is my I/O start logic. By default, the drive is set for a rising edge, which could become an issue if you have a power failure. The drive will not restart by itself. It will be looking for somebody to turn it off and on again. So we're going to change 2.4 to 0. And that will always start the drive by default, whether the power is on or off. Now we're going to pick the next one is 3.1. 3.1 is the minimum frequency. That'll be according to your motor or whatever specifications you've got. I'm choosing 20 on this. 3.2 maximum frequency, normally 50 for us. And we're going to go to 3.3. 3.3 is where we are going to choose the PID loop. So we're going to be using the drive to be doing the PID. By default, it was just looking at analog input 1 and would have been a standard application, but we're going for a PID. So we're changing that to 6, which is PID. Then we're going to go all the way over to 15.1. 15.1 is going to be the set point source. So where are we choosing the set point? In this case, the drive is doing this, so we're going to choose the keypad. 0 is the keypad. 15.2 is the actual set point. We can choose this. This is in percentage. It says so over there. So you can choose whatever your percentage for your set point is going to be according to the sensor you're using. So I'm going to pick 40% here. The feedback source would be 15.4. So that would be analog input 1 or analog input 2. Analog input 1 is 0, analog input 2 is 1. So we're going to pick 0 because that's where I've got my transmitter connected to. 15.1, 15.10 should I say, is error inversion. So normally for pumps and fans we go direct, 0 is direct, and for gases, CO or CO2, it's the other way around. Then we would make that a 1. 0 is what we wanted there, so we're going to leave it there. Then the next one, 15.11, is sleep frequency. So the drive will automatically go into sleep if the feedback is less than the minimum frequency for a certain amount of time. But if you don't want this, then all we're going to do is we're going to go to the setting and we're going to make it whatever our minimum frequency is on the drive. And then the drive will not go into sleep mode. It all depends on your energy savings in the building. And that is it. We can go back to now monitoring. A few parameters we can monitor. We can start the drive. and it will act as a perfect PID loop now according to your feedback that you're getting from your pressure transducer, and it will act accordingly. My pressure is a bit low now, so the fans are slowing down, but if I turn it up, the drive will start ramping and it will get to 50 Hertz, and vice versa, a proper PID circuit. Thanks for watching.